Alright, molar mass in compounds. Yesterday we dealt with atoms. We dealt with finding molar mass of atoms. And molar mass in compounds is pretty much the same thing. But in a compound, and we'll use a simple one to start with, H2O again. In order to find the molar mass, so to find molar mass, add the molar mass of all atoms together. So it's, like I said, it's not rocket science yet. We're getting close to it, but we're not there yet. Now, how many hydrogens are there? There's 2. So this is one way you can do it. H and H. How many oxygens are there? 1. Now, we could go to our periodic table. Hydrogen, what's the molar mass of hydrogen? 1.01. So 1.01 and 1.01. Now, what's the molar mass of oxygen? 16.00. So 16.00. Add them up.
18.
I'll draw a line there because that 0 looks like it's encroaching on the number. That's a 2, that's a 0, that's an 8, that's a 1. Grams per mole. That's it.
Is that it?
That is 100% it. Now, there's actually an easier way than this. With water, there's only 3 of them. It's pretty easy to go that route. Now, let's go back to our friend dioxin.
Why don't you go to sugar?
Why don't we go to dioxin? C12, H4, Cl4, O2. And we want to find the molar mass. So basically I'm giving you an easy example and I'm giving you a crazy one. And I'm going to show you that the crazy one's not all that bad. Now, there's 4 elements, right? There's carbon, there's hydrogen, there's chlorine, and there's oxygen.
Can we multiply it?
Now, chlorine, or carbon rather, is 12.01 grams. Hydrogen, we know, is 1.01. Chlorine, 35.45. And oxygen is 16.00. If I were you, I would kind of remember that oxygen is 16. Carbon, what's the carbon that we use for moles? Carbon 12. So carbon is 12, but it's actually 12.01 because the 0.1 takes into account the fact that there are multiple isotopes of carbon. So that's where it falls into place. Now, we talked about ratios earlier, and we had a nice video on the ratio, so you can go back and check out the video on the ratios and all that. How many carbons actually are there? 12. So I could take this number, multiply it by 12. How many hydrogens are there?
4.
There's 4. So I can take this number, multiply it by 4. Thank you. How many chlorines are there? 4, so I could take this number, multiply it by 4. Then oxygen, how many of those? 2. So I could take this number, multiply it by 2, and then add them all up. Now that's a lot of math. Now, that's why I say this calculator ends up being your friend when we do this type of a math calculation. Because with this calculator, you can type in at the beginning 12 times 12.01 plus 4 times 101 plus 4 times 35.45 plus 2 times 16, and you can get your answer. So instead of doing everything part by part, the Inspire, which we have in the back, we have a full set, all you have to do is hit enter, and you get your 321.96 grams per mole.
So it's okay if you don't show our work?
This is your work.
Well,
All this is your work.
Like we don't have to show all multiplication adding all
I want to, what I want to see is this and this. I want to know that you understand the ratios. I want to know that you understand that it's going to be that ratio or that number of atoms times the molar mass. So I need you to go in and be able to get molar mass for all of them. If you set this up and then come up with an answer, that's as much work as you need. Because I know we have the technology that'll take care of this. So using this calculator works out perfect for that. Now, if you have a scientific calculator, let's see if we get the same answer by doing the same thing. 12 times 12.01 plus 4 times 1.01 plus 4 times 35.45 plus 2 times 16.00. Now, it's old muscle memory that I type in the 0.00. If you typed in 16, you'd be good to go. Hit enter. Is that the same value?
No, you typed it wrong.
I typed it in wrong.
I did it and I got the same answer. You just
There it is. Same answer. Now, before, when I typed it in wrong, I got the wrong answer. On a scientific calculator, do I know where I typed it in wrong?
Yeah. Oh, no, on this one, no.
No, because once you do it, it's gone. It's gone. And that's why either the scientific calculator that has the row in the top where you can put everything in and get the answer, or a regular calculator where, or the TI Inspire where you could just type it all in and get your answer. Those are the best ones to do because there's 1, 2, 3, 4, 5 different operations that are going on here. 4 multiplications and 1 addition. There's 1, 2, 3, 4, 5, 6, 7, 8 different numbers. 4 of them are decimals. So there's a lot of opportunity for error throughout this whole thing. So setting yourself up with the tool that is going to give you the best answer is probably the best one that you want to do. I would say that being able to find molar mass for our compounds is going to be a big idea, and it's going to be a huge thing when we start talking more about reactions, because now based on the formula of our compound, which is right there, we're going to know what the mass is. And then if I said, I want 35 grams of this, I'm going to know I can use the formula to figure out the molar mass, and I can figure out all sorts of other things. And I can figure out what plus what is going to give me what I need. And this is what chemists do. Chemists do a lot of calculation like this. Now, granted, a lot of it is probably thrown into a computer and they get done. But the idea is that you need to know how much of each substance you're using in order to, because we're going to be able to predict what the final answer is going to be. And we'll do the math before we do the actual experiment. And so we'll say if I have 10 grams of this plus 15 grams of this, I should end up with X grams of this and Y grams of that. So then we can do our experiment and see if we did it right and see if everything came out right. So that's what we're trying to do, and that's where being able to figure out the molar mass of a compound is going to be so important. So that's kind of like a preview of what's going to happen as we move forward through the different reactions that we have. we have to know the amount that we start with and the amount that we should end up with. That's going to be hugely important, because if you're coming up with the wrong stuff, then something's going wrong in your experiment. An experiment, even though it's an experiment, our experiments are going to be pretty much well-defined and not just unknown type experiments. This is one of the big steps that you're going to want as far as that.